So the folks at Epic Games have just announced Unreal Engine 5.6 to preview, and this comes with a couple of interesting features. A lot of bug fixes and of course a couple of things that we will be taking a look at, which has to do with the roadmap of the coming version of Unreal Engine. And for those who like to get this, all you need to do is to go over to unrealengine.com, and right here you will be able to download the Epic Launcher. And once you download Epic Launcher and fire it up, you would also be able to download Unreal Engine 5.6 to preview. Now there's a couple of things that are here that you might want to consider taking a look at, and one of them, which is something I believe a lot of people will be super excited about, is the MetaHuman. So the MetaHuman creator is now part of Unreal Engine 5.6, and we're going to take a look at how you can now work with this right here in Unreal Engine. And to get things started, you need to make sure they have this checked in, and you can also go ahead and turn this on as well. If you like to work with Android, iOS, tvOS, or Vision OS, you need to also go ahead and check these too. And once you have them ready, you can click on the apply button, and this is going to initialize and download all of them this on as well. If you like to work with Android, iOS, it's checked in, and you can also go ahead and turn this on as well. If you like to work with Android, iOS, and one of them, which is something I believe a lot of people will be super excited about, is the MetaHuman. So the MetaHuman creator is now part of Unreal Engine 5.6, and we're going to take a look at how you can now work with this right here in Unreal Engine. And to get things started, you need to make sure they have this checked in, and you can also go ahead and turn this on as well. If you like to work with Android, iOS, tvOS, or Vision OS, you need to also go ahead and check these too. And once you have them ready, you can click on the apply button, and this is going to initialize and download all of them, just in case you didn't download them initially. And once this gets downloaded, you can now hit on the launch button to launch Unreal Engine 5.6 to preview. Now, unlike what we mentioned earlier, when we talked about all of the templates that were supposed to come over to Unreal Engine 5.6, in this release, those templates are not yet here. So hopefully in the final release of Unreal Engine 5.6, we possibly will be seeing those templates and seeing how we can get started with them. Now, for those who are thinking about the templates and all of that stuff, we already made a video where we talked about features of stuff coming to Unreal Engine 5.6. You might want to reference those videos to see some of the cool templates that are supposed to make their way to the next version of Unreal Engine, which supposedly should be Unreal Engine 5.6. So with Unreal Engine 5.6 open up right here, you would notice that the UI looks slightly different. So right over here, you would see that the menus have changed. So this is pretty nice. I kind of love it. So right here, you would notice I've got select, move, rotate, and scale. Right here, coordinates exist right over here, which has to do with world and also local. Right over here is where we have all of the snappings. So you want a grid snap, you want a rotational snap, you have that there. And of course, you can turn this on and turn them off simply clicking. Right here, we have the units at which we can snap. So you want to make 1, 10, you know, all of that. You can do that, and of course you can turn them or turn them off. Right here we have a big camera option which deals with perspective and a lot of other things. So you want to create bookmark, cameras, all that, you have them there. You would also notice that we have our camera movement. The light is here, so we can simply play with anything that has to do with lighting right here, and we can also show or hide stuff by simply using these two. So these are very nice, and I love how simple and of course how standardized this whole thing is. Now you can also switch from a full perspective to a quad layout by simply clicking on this button, and if you like to do a quick render, you can hit that button to do your quick rendering. Now there's a lot of controversies about how this UI is looking, and the cool thing with this is at this point you can choose to turn this on or turn it off. And to do that, all you need to do is come over to the command line, and you can type in the word tool menus viewport, and once you simply type in 0, pressing the enter key, this gives you the previous one. So this is the old one, and of course if you really love this one, you can simply stick with it. I kind of like the new one, and you know, I think it's modern.
Like
it's, you know, a little bit more straightforward for those coming to Unreal Engine for the first time. Now another cool thing is if you're battling between the new one and the previous one, simply type in tool menus viewport toolbar 1 and pressing the enter key, and you can have them both. Like, why not? Like, you can definitely have them both, and you can easily transition from the previous one to the new one. And by every means possible, if you just want to work with the new one, you can dial that in, type in the number 2, press the enter key, and there you go. You have yourself the new one, and this looks pretty cool. Now, something else which is also pretty cool is how you get to model with this. So if you simply go over to the modeling section, this now offers you a more traditional approach for modeling. So to experiment that, we can simply go in and drop in the box, click on accept, tap F on the keyboard to frame in that box, and we can simply rotate around that. Now, right here, you would notice that we have vertices, edges, and triangles. And this is for those who like to simply start modeling. So you can simply jump into the component mode really quick and start modeling with this. So if we like to simply control the vertices or simply move vertices of a model piece, we can now do that. So I can have that selected, and we can just move that down if this is what we want. If you like to play with the edges, of course you can simply select the edge and have that selected, and we can simply go in, bring that down. And for those who like to play with the triangles, we can of course go ahead and have that selected. Now if you want to work with faces, these are considered as polygroups. Now to get things going, we can either play with the vertex polygroup, the edge polygroup, or the faces. Faces are considered as polygroups here, so we can have that selected. And in case you want to make some insertion, some extrusion, or maybe beveling, you can do that by simply going over to the select section, and we can now do some insertion. So we can make some inserts like so, and of course we can make some extrude like this. So we can have that. We can play with whatever property that we want right here that has to do with the extrusion. We can make it fixed mode and interactive mode. All of that is right here, so you can make all of that changes. And once you're ready, you can hit the accept button. And for the beveling, we can of course go ahead and make those bevels. So in this case, we might increase the distance of the bevel if we want. We can also play with how much subdivision for that bevel that we're going for. If you want this to have a more rounded weight or not, you can have that sorted out right here. And once you're ready, you can click on the accept button to get things going. And this looks pretty neat, especially for those who are trying to get into modeling, or potentially you want to start making your models right here in Unreal Engine. Of course, there's also a couple of other nice cool stuff that has to do with the form, the whole model stuff, and also some mesh operations that are now easier than ever to work with right here with the new toolbars that exist for Unreal Engine. At the same time, there's a new update to materials, and you can now preview one texture or one simple texture node by simply going over to the node and pressing the playback button, which is technically the preview button. Now, there's a little bit of a bug in between these two, because at this point, once you press the first playback, you actually see it say preview, but it doesn't reflect here. You have to actually press this again for this preview to be happening. And once you press it again and it says previewing, it's technically no longer previewing, it kind of stopped previewing. So I think this is one of those things to keep in mind. So another thing you would notice, every single time we hover across stuff, is the tooltip, as the tooltip has now been improved. So at this point, if we hold down Option and Command, because we're using a Mac, you notice that we have a nice tooltip right there. If we go over here, hold down Option and Command, you'd also notice that we have a bit of a nicer tooltip overall. So you can actually go across various stuff and see a proper tooltip that explains them better. Back to the materials. If there's any material node you like to preview, all you need to do is just simply hover across them, press the playback button, and you can preview that material. In this case, we can see what the diffuse color map looks like. If we like to see what the left looks like, we can press the playback button, see what the left looks like.
That's so
if we like
cool.
to see what everything looks like, we can just simply, click one more time to stop that from previewing. And I guess this might be a bit of a bug and something that they might fix later in the future. There is a bit of an update to the color picker.
Very nice.
So we can go in, mix some stuff up if we want, and if you like to use the eyedropper, you want to toggle with color teams, or maybe you just want to use a spectrum wheel or something like that, you can of course toggle this back and forth and work with that. And so if you do have nodes that you would like to preview, or possibly you would like to just play with, these are some of the options that are now available for materials. More so, if you're working with MetaHuman, there is now a MetaHuman creator which is baked directly into Unreal Engine 5.6, and it is worth exploring. One thing to keep in mind is if you're working with a Mac, this is currently not available. However, if you're working with Windows, you can have access to it. And how this works is pretty simple, as all you need to do is go over to Edit, go over to the plugins, and dial in MetaHuman. And once you do that, make sure you check everything MetaHuman, so from the live link all the way to the runtime, and more especially the MetaHuman creator. So once you have all those checked in, you can now hit the restart button to restart Unreal Engine. And once Unreal Engine restarts, simply confirm that you have all of that enabled, and you can now proceed to start creating MetaHuman right within your content browser. Interestingly, there's a MetaHuman manager which you'll find if you go over to the Windows section, scroll all the way down to MetaHuman, and you'll be able to manage character editable, character assemblies, character skeletons, character outfit, and also groom. But in this case, let's just explore the brand new MetaHuman creator that is now available with Unreal Engine 5.6. And so once we create a brand new one, we can simply double click and this loads in. And once this loads in, it's interesting what we have. We do have a nice looking user interface that just mimics exactly what you have on the web, and navigating with this is pretty standard. You use the typical Alt left click to orbit, Alt middle click to pan, and Alt right click to zoom in and out. And by default, how you work with MetaHuman is by blending. And in this case, there are some sort of blending options that are available, but at this point there are no characters, or should I say presets, to support it. However, it doesn't stop you from actually working with some stuff, as if you do have your own DNAs, you can simply use the conform tool, import the DNAs and work with them. In terms of the model, you can definitely go in and start making some adjustments to the model. For example, if you like to make adjustments to the teeth, make something that looks pretty cool, you can definitely go ahead and make those alterations. You can do the same for the eyelashes, and you can proceed to sculpt your model how you want. In this case, we're simply going to use the very symmetrical sculpting to get started, and we can break that out by turning off the symmetric to get a bit of an asymmetrical model overall. One thing that you would definitely notice, which the folks at Epic are particular about when it comes to MetaHuman, is how it looks. And so the material has been given a huge update. So you can definitely go ahead and play with the material however you want. If you're into texture indexes, you will definitely find this one super useful, as there's a couple of texture indexes that you can use for both the body and also for the face. The face one is more visible, as you can definitely see those wrinkles. You can go through the indexes and get some cool stuff happening for you. If you like to play with the contrast, the roughness, or maybe the overall strength of the freckles, which is currently available as a preset, you can dial those in. In several instances, you might want to be able to create the combined skeletal mesh. Now, before you do that, I would definitely suggest that you do this instead. Go over to the MetaHuman character menu within the MetaHuman creator, and then proceed to export the face skeletal mesh and the body skeletal mesh. 3rd of June 2025 in Orlando, Florida. And for those who like to add this to the calendar, or probably you like to stay tuned, you can simply come through so that you can catch up with all of the big updates and news that will be happening with Unreal Engine at the time. Furthermore, if we go over to the roadmap, you would notice that we've got lots of things coming over to Unreal Engine 5.6, and this is happening across various sectors, from rendering all the way down to modeling. And within the rendering section, the Lumen hardware ray tracing optimization seems to be something that's coming. There's also updates to the rendering hardware interfaces that deals with rendering parallelization and bindless resources. We've also got Niagara heterogeneous volumes, virtual shadow map optimization, substrate materials, depth of field, GPU profiler 2.0, and the first-person rendering as well. And for animation, the sequence organization seems to be coming. We've got some seamless gameplay transition cinematics, and this is going to be huge for animators. And we've also got some nice looking stuff that deals with both gameplay, theming, retargeting operation stack, and the relative time scaling for sequencer. Now for retargeting, there's some cool stuff coming to that. As we simply scroll all the way down here, you'll notice that scaled proportion retargeting is definitely going to be looking super useful when this comes in. And this is going to be good for those who are into working with motions, you know, animations, motion capture stuff. This is going to be super cool. And if you want more resources about that, we've made a couple of videos. I'm going to put some links in the description that can definitely guide you through that. And for those that are into control rig, there's also the control rig physics, which is currently in experimental. The sculpt morph shape is definitely something that we should also take a look at in our subsequent videos, and you'll definitely find more stuff that has to do with animation right here. For world building, there's some cool stuff. Procedural content generation has some cool stuff happening for it. We've also got some nice looking stuff right here within the developers iteration. And for those that are into audio, or possibly
stop scrolling so fast,
design, we do have some nice stuff right here, as cloners and effectors are getting a huge update. Photoshop layer import is also having a nice looking update. We've also got some content pipeline that's also having some nice looking improvements right here, and this includes the FBX, the interchange workflow improvements, and of course USD is having some stuff. So lots of things are coming over to Unreal Engine, and of course if you'd like to download these and test it out, yes you can. And speaking about things that you might want to test out, there are some bugs and also some fixes. So there are certain issues for Unreal Engine 5.6 that have been fixed. You can definitely come through, check these ones out, and of course they have some unresolved ones. Definitely there are more fixes that has been done for Unreal Engine 5.6 and 5.6.0 as opposed to the fixes that are yet to be done, and you know, some things are yet to be resolved. But either ways, Unreal Engine 5.6 is looking pretty stable, and lots of things are coming to it, especially for those who like creating content and working with this engine. And speaking about artists or creators that love working with Unreal Engine and creating stuff, if you're into world, or maybe you want to get started with Epic Games Unreal Engine and check out some of the cool features coming to it, then links to all of this is going to be in the description, so do want to check them out. Tell me what you guys think about this one in the comment section, and of course if you like this video or you like something from this, you can go ahead and give a like, and don't forget to share with a friend. And I'd like to see you guys in the next one. Peace.
Critical. Why this? Oh, why? Why? Oh, the kinematic. Oh, this is so nice. Very cool. Chaos Flash. Very cool, very cool, very cool. I still have to play with the chaos destruction thing. All thing, but it's so cool. What the fuck? The chair is all the way up there floating. Kinda lost now. Okay. These are about what? Clouds. Pause thing, right? Really nice. Looks good. Makes a little bit harder for one to transition to PoE to build. Boom.
Hello and welcome. In this lecture, we're going to be creating a factory room and adding windows in, all using Unreal's built-in geometry brushes. Let's dive in and see how they work. So it's not generally best practice to be editing the default minimal level. We want to be creating our own. So let's go ahead and do that first of all. We're going to go to the File menu and hit New Level and select the Template Default and hit Create. In your engine versions, your choice is going to look different. In this case, instead of using Template Default, please use the Basic here and click Create. And you're going to end up with a level that looks a little bit different to what you're seeing in this lecture, but for all intents and purposes, it should serve the same purpose. And this gives us a little world with a nice sky sphere so that we've got clouds, and but some of the default lighting in here is good too. So that's a good start. I'm going to delete the floor, because what we're going to be doing in this lecture is creating our own geometry, blocking out geometry using the built-in Unreal geometry brushes, which are sometimes also known as BSP, which stands for binary space partitioning, which is really the technical details of how they work, so that's not as informative. I will be calling them geometry brushes. Now, the place that we go to add geometry brushes is the toolbar to the quickly add, and then we go to the place actors panel, which is going to give us lots more functionality than that little menu provides us. And then at the top of the place
Seconds, motherfucker.
Actors panel, you can see there are different sections, and one section is the Geometry tab. Let's go ahead and click on that, and you can see the basic building blocks of geometry that we can place with geometry brushes. You've got stairs, you've got spheres, cylinders, cones, and boxes. So we're going to start by putting in a box brush, and you can see that it instantly starts with a little bit of a wireframe, and then it fills it out. And that's because these brushes can work in one of two ways. They can build up your geometry by kind of creating it, or they can carve it out by subtracting it. And that's what we're going to do here. We're going to create a little bit of a warehouse room, and we're going to achieve that by creating an outer box which builds out a box that's the entire room, and then we're going to carve out the inner section. So let me show you how this works. First of all, rename it in the outliner so we can keep track of it. So select the box brush in the outliner and hit F2 to rename it, and we're going to call this the walls. Then we're going to go ahead and scroll down in the details pane to where it says brush settings, and this gives us the size of the brush. Now you can scale brushes up and down using the scale property of the transform, but that's not recommended because it's not going to correctly scale materials when we apply those later. So don't touch the scale properties if you want your materials to look good. Instead, go down to your brush settings and you can tweak the size in here. So I'm going to size my room to be about 34 meters long, so that's 34 times 100 in centimeters. It's going to be 27 meters wide, and the height I'm going to give, which is the z-axis, is going to be 7.6 multiplied by 100, which gives us 760. And that's going to give us a roughly kind of sports hall sized area, hopefully. And we can tweak this when we bring in our assets to just check whether they are the right size. Then the next thing we're going to do is we're going to take our walls brush and we're going to duplicate it by selecting in the outliner, doing a copy and paste. And I'm going to call this walls subtract. And we'll see why we called it subtract in just a second. But we're going to go over back to our walls brush because I want to expand that walls brush so it's slightly bigger than the walls subtract brush, which is going to slot inside of it. So what I'm going to do is I'm going to go to each of the dimensions X, Y, and Z in the brush settings, and I'm just going to add 200, equivalent to adding 2 meters to each one of these. And with that done, we're going to go back to our walls subtract brush in the outliner and scroll down to the brush settings where it says brush type. Here we want to select, instead of additive, we want to select subtractive, which means that this brush is going to carve away geometry rather than add it into our scene. Once we do that, you can see that we've got a little room, because what we've...
Wow! Okay, guy, I see what you've
done is we've created a solid volume with the walls brush, and then we've taken away the scooped out the center using the walls subtract brush. Now, before we go any further, we should save this new level that we've created. So Control S will bring up the save dialog, and we can put it in the root of our content. I'm going to call this the main map, just like that, just main. And what we want to do is also set it as the default when we start up the editor and when we start up the game.
Yeah,
so we go to the settings button on the toolbar, project settings, and then with our project settings, we go to the project section in the left and maps and modes. And then here there are two properties we want to change, the editor startup map and game default map. Both of these need to be our new main level, and then we can go ahead and close our settings again, and this will open up in the future when we open our project. Now, I'd like at this point to bring in some of the industry props that we have, and the way we're going to do this, I'm just going to clear the filter by going to the filter button and hitting reset filters. Then I'm going to open the industry props pack folder. Then I'm going to go into meshes, and I'm going to bring in the tallest item I know of, which is the rack. So I drag in the rack into the scene, and you can see that the size of this rack is just about right for the size of the room. So I'm fairly happy that we've created a good size of warehouse. Now, I'd like to challenge you to make some windows. The way we can do this is by adding some new box brushes into the scene and making them subtractive, first of all, because we want to carve out those windows, and then position them in the walls and size them appropriately so that they punch holes through the walls and give you a nice window. Pause the video and see if you can do this.
Yeah, of course I can. I'm not that dumb motherfucker. Can do this. We just... First and foremost, let me do... the group now. Oh! Groups, ungroup. What I want to do is create a folder. Now let's do what. Greedy thingies. Ow! The middle. No. Ow, cold. Just use dice. Like a sphere. Fucker, how does this sphere does not? All fairly small. Farm. Somewhere. Ah, here. 5. Okay, now it's so cool. Oh, didn't play for you also. Let me relog. I'm sorry. Okay.
Okay, welcome back. Let me show you how I would approach this. So I'm going to start off by making a hole in this wall to my left. I'm going to take a box brush and drag it onto the wall itself. Now, I want the size, the dimension of this to be large enough so that I can poke it through the wall. So first of all, let's go down to make it subtractive. So we go to brush type and change it to subtractive. And then we're going to push it through the wall until it makes a nice little hole. So there I've got a window already, but what I want to do is actually change its height and width a little bit. So its height would be the Z dimension. I'm going to try making that 400 and see if I like the look of it. Yes, it's a nice tall window. Looks a little bit industrial. So now we've got a window that I like the look of. I'm going to rename the actor in the outliner. So I'm going to select it and hit F2, then I'm going to call it window, just so we've got these windows named and sorted. Then I'm going to hit Alt while dragging on the red arrow to create a duplicate window that comes out named as window 2, which is great. And in fact, I want to put these windows all inside a folder in the outliner, so I'm going to select them both, right-click them, and click Move To, create new folder, and call this Windows. Then selecting our window 2, I can keep dragging all the way across the room. Remembering to release Alt between dragging, and that creates a new duplicate every time. And then to make a copy of those windows across the room, I'm going to select them with a shift click in the outliner, and using an alt click on the green arrow, I'm going to duplicate them onto the other wall. And there you have it, windows on both sides of our newly created Geometry Brush factory room. I'll see you in the next lecture.
Or acht. What? $13. Yes. Oh, big suit. Beautiful.
Hello and welcome. In this lecture we're going to be making our level look a bit better by putting in some proper materials and adjusting the lighting in our room. Let's dive in and see how to do this. So since we've migrated to our new level here, we have lost all the functionality that we had in our previous level. If we go ahead and hit play, we can fly around this level, but hitting spacebar just makes us go up. So how do we change that? Well, fortunately, we can easily copy our functionality over from the old level. We just need to go and find it in the starter content maps folder and open up minimal default. Then we need to open up the level blueprint from the toolbar and then level blueprint. And then we can select all of the nodes in here by doing Control A and then Control C.
For me, it's easier to study and look up for things. I think it's nicer to do on stream for now.
Content drawer again, we can go to the root of content, open up the main level, and then open up its level blueprint by clicking the drop down and opening level blueprint. And then finally, when we're in here, we can select everything and delete all the nodes that are currently here, and then just Control V to paste in the functionality that we wanted. And now if we hit play in the toolbar, you can hit spacebar and fire the cannonballs. Sometimes they go through the walls, which is kind of funny, but you can fire the cannonballs at the sea.
Okay, I will do that then. I missed something. Why my balls are not... What? Every ball is going through. What? What's happening? Why? What is this sorcery? The floral. Quest for. I have no idea.
Now, the most obvious thing that is wrong with this scene is that there are no materials whatsoever on the floors and ceilings. That is something we need to fix. Now, fortunately, we've got some great materials in this project already that came from the starter content. But if we wanted to filter just for all the materials, so whether it's in the industry props pack or in the starter content, then we can do this quite easily by going to the little filter button to the right of the search bar in the content browser, and then going to materials, and then checking the material filter. This will automatically go and look for all materials that we have in our project. So we could do things like bring in a grassy wall, and we can drag that material onto a surface of our geometry brush, and we've got ourselves a grassy wall, which isn't exactly the most conventional wall material, but it certainly illustrates the point. And one more thing that we can do to tweak our environment here is look at how it's currently being lit. If we look at the outliner and search for light, then you can see that there are a couple of light sources in here. There is an omnidirectional skylight, which is just sending in light from all sorts of directions and giving us a kind of fill color. And there is a directional light, which is called the light source in this case, and that reflects the way that the sun lights our scene. So you can see that the shadows coming in from the windows are quite a harsh angle here, and that's because of the sunlight angle. If you double click on the light source, you can see the icon for the directional light is a sun with an arrow showing the direction, and we can use the rotate tool to change the directionality of that arrow, and so the directionality of our sunlight. So we can extend the shadows, change the direction of the shadows, and have them cast against a wall or have them come further into the room as we wish. So you can mess around with that to your heart's content to light the scene in the way that you would like. So let me challenge you to decorate your own room. I'd like you to choose some materials you like and drag them onto the floors and walls and ceilings, probably choosing something different and something that matches with an industrial vibe against the floors and ceilings, and something that makes sense. Or you could go completely wacky, wherever your heart takes you in this particular instance. And then I'd like you to adjust your lighting as well to however you like it. And once you're done, don't forget to go and share a screenshot of what you've created in the discussions below this lecture so other students can see the great work you're doing. Pause the video and have a go.
Okay. Where is it? Oh yeah, I blocked the move. Ta-da! I have to change. Nothing is changing. Oh, pretty. Cool, let's do it like. Looks like shit. Perfect. Are you kidding me? I do this for every. Probably there is a better way to do this, right? Trying to. Can I do here? What can I do here? Edit something, and with that we would apply the texture. Look, I saw something about converting, did it? Oh shit. $30. Know what? Pop this toggle. Oh, estudando um pouquinho. Got the grasp, I don't have to do everything. Beautiful. Marble, concrete. Ah, this looks nice. Yes, yes, yes. Better than the marble. What's going on? What's going on? It applied the texture to the eye box. What? Mas agora a gente consegue equipar os itens, A gente consegue equipar os itens, trocar os itens. Tá pog. Pog. Vê? Se não quer, vai ver mesmo assim. Mas pera, você tá aí ainda? Senão... Issue here. Eu taquei o bagulho de vidro. Só que agora, em vez de eu poder tacar outro bagulho de outro material, ele tá atacando no... Como é de vidro... What the fuck, Unreal? O material é de vidro, então agora quando eu jogo ele passa em vez de... Que idiota. Ai, 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 Jesus amado, velho. Como que os caras fizeram um negócio desse? Pera, isso significa que se eu desligar... Sure. A música decente. Vendo? Tô com os itens equipados agora. Pororão. O item. Agora eu posso spawnar as coisas direto. E de qualquer item que eu tiver. Deca Shield tem 18. Já dá pra fazer porque só esse não é estacável. Então eu não testei isso. Equipou e exibiu. Nossa senhora, isso é a Body Armor. Hã? Achou. Parece uma maravilha, tipo, cobre a mesma quantidade, né? Ah, é porque crashou. Spawnar os bichinhos também. Muito ok. Gato. Pá. Pá. Craftar a vitamina. Já visto, eu acho. Ando. A não ser que eu tenha falado pra ir pra chest. Não sei o que. Ah, sim. Falta um. Mas uma coisa, tá vendo que minha vida tá assim, né? Dessa bug visual que tá acontecendo. Alguma coisa que tá por cima de tudo aqui que não é. Eu não consigo. Enfim, já tá dando pra consumir. Ah, obviamente. Já. Armored Mock. Ah, tá errado o nome. É por isso. Tá tudo cagado. Cara, esqueci. Achando inventário. Estado do jogo. Og, né? Sim. Tem que contar um monte de outras coisas que eu fiz que eu não falei, né? Acho que eu falei. Pra prevenir a galera mudar os horários, né? Porque como vai... Pode deixar o jogo ligado e ele vai continuar jogando, né? Ou pra você não poder roubar o jogo e ter um monte de evolução, eu... travas de segurança. As mudanças do tempo, essas coisas. Pra ficar tudo certinho, né? Coloquei essas travas de segurança. E... eu faço uns cálculos também. Quer dizer, tá pronto para eu fazer. Ainda não tá funcionando, mas não tá aplicado, mas tá pronto para fazer cálculo tipo, quantos bichos você conseguiria matar offline com a gear que você tá, sabe? E aí eu comparo com quantos bichos o server tá recebendo e tudo mais para garantir que, poxa, não estão engambelando, né, a parada. Tá ventando bastante. Aqui tá tá um tufão aqui. Aí não, tirou o exploit. Yes. Sem exploit. Bom, sem exploit não, né? Sempre alguém, o filho da puta, vai achar alguma coisa, né? Vamos ver o que vai acontecer com o tempo, né?
Okay, welcome back. So obviously I'm not going to keep grass on my wall. I think my walls will probably be some sort of clay brick, so I can drag that onto the wall instead. And there you go, we've got a nice bricky texture. I'm just going to repeat that on my other walls. Okay, that is done. Now, I haven't been completely complete about this because you would have to drag the texture onto each of the windowsills as well. But because they're a little bit far off in the distance, I'm not going to bother with this on screen. And you can, of course, do this level of polish if you so desire. But next up, I'm going to bring in some tiled concrete material for the ground, which I think gives us a nice rustic look. And then finally, for the ceiling, I'm going to go for these concrete panels material.
Oh, põe o glass, põe o glass.
And there you go, a very rustic looking ceiling. So finally, let's hit play to test this out and see what it actually looks like once it's all illuminated. And I'd say looking pretty good. We've got some nice light in here. It's quite airy, and we've got the right sort of scale for our props. That's it for this lecture. I will see you in the next one.
Yeah, okay, motherfucker. I don't. This is so dumb. This is just for the law. And then I can. Fuck, this is a horror game. No. Fuckers. Way that I can't do this. Fuck. The fucking thing. Why this is so dumb. Apply on the outside now. Why? Tell me why. Why can't I apply this here? How many undo? Okay. Nothing like a little bit. The fucker, man. Motherfucker. The cool little. Yep, concrete poured it is. Okay.
Hello and welcome. In this lecture, we're going to be looking at how we can add multiple components to an actor so that we can have multiple meshes and a more complicated actor that acts as a single unit when it comes to physics. Let's dive in and see how to do this. So now that we've got a decent looking level, let's look at putting together a little bit of a diorama for us to knock down. Now, you'll notice that when I dragged in this rack mesh, it created an actor but doesn't have any rack elements inside it. Now you could go ahead to go over to the content drawer and just cancel out the filter here by clicking on the filter button again and just hitting reset filters, then going to the content folder, the industry props meshes, and looking for the actual rack item itself. I can drag that into the scene, but you'll notice I would have to very carefully position this. And what happens if I enable physics on both of these items? If I go ahead and hit play, you see that they kind of work. They kind of stick together to each other but then if you hit them, this kind of weirdness happens because they aren't cemented together as one single item. So if we want to make a single item out of multiple of these, what we need to look at doing is having multiple components. So when you select either one of these actors, you'll notice that they are actors that contain a single component, a static mesh component. We've seen this before. But you can have more than one of these static mesh components. You can add actually as many of them as you like. One of them has to be at the root of the actor, and the other ones will be children of it. And let's just have a look at what that means. If I first of all delete the rack actor that I brought into the scene, I'm going to open up my content drawer, and instead of dragging on to the viewport, I'm going to have my rack 1 selected, the vertical blue bars, and I'm going to select my rack 2 and drag it onto the static mesh component. And you can see it gets nested just underneath the first static mesh component. So that's what I mean by it is a child of that static mesh component. And what that means is that if we move the actor or the static mesh component, the rack will move with it. So the position of the rack, if you click on that rack component, you can see that the location is currently set to 0, 0, 0, but that's not true. It's not at 0, 0, 0 in the world. If I look at the rack says it's got a whole bunch of numbers, 1,000, 600, and even some offset from the ground. So why is this rack 3 within it showing something different? Well, that's because when you are a child of another component, your position is relative to the position of the parent. So if I were to move this component, if I select the rack 3 component and I move it up along the rack, then you can see that the only change to the location is that Z movement that I've added. And that gets applied along with the position of the parent in order to give us the overall position of that component, which is very handy because it automatically means that whenever we move the parent around, the child is going to move with it. And by the way, exactly the same thing holds if I were to rotate the parent, it also rotates the child. If I were to scale the parent, it also scales the child. But let's undo the scaling and rotation for now because I'm quite happy with it as it is. So I'd like to challenge you to add another rack. The way we're going to do this is by adding a second child component to that actor. It's going to be a sibling of the first rack, but a child of those blue bars. And you need to enable physics on the root, so on the topmost static mesh component, and see what happens when you play. What happens now if we hit it with one of our ball bearings? Do we get any of that weird glitching?
We make sure that we still have. Oh, I'm not simulating physics. Now let me take. Cool. Oh. There. I don't know. Yep. Okay. That's okay, almost everything. That's let me see if I can find. Ah, hey, pretty cool.
Okay, welcome back. So I'm going to do this one of two ways. So you could drag it in from the content drawer, or you could select the rack component in the details pane and copy and paste it to get a second one. You can see that these are now siblings. We've got a rack 3 and a rack 4, and we've got a root static mesh component. I keep calling this the root because the way this works with actors is that one of these components always has to be the root component, and it's actually the position of the root component that tells us the position of the actor. The actor doesn't have a separate position. It is only that position of the root component. So what we can do now is we can move this second rack up a little bit so that we've got a nice kind of layout here, and then what we can do is select that root static mesh component, select the physics category, make sure we've got simulate physics enabled, which we do already, or at least I do. The other two racks should have it disabled, so the two children should have it disabled, and if you go ahead and hit play now and launch a cannonball at this rack with a good aim, you can see that the whole thing has now been welded together and it moves as a single unit, which is much more as we want it to be. Great stuff. That's it for this lecture, and I will see you in the next one. Hello and welcome. This lecture we're going to be sorting out the colliders on our barrels so that we can of the root component that tells us the position of the actor. The actor doesn't have a separate position. It is only that position of the root component. So what we can do now is we can move this second rack up a little bit so that we've got a nice kind of layout here. And then what we can do is select that root static mesh component, select the physics category, make sure we've got simulate physics enabled, which we do already, or at least I do. The other two racks should have it disabled, so the two children should have it disabled. And if you go ahead and hit play now out and launch a cannonball at this rack with a good aim, you can see that the whole thing has now been welded together and it moves as a single unit, which is much more as we want it to be. Great stuff. That's it for this lecture, and I will see you in the next one.
I guess that makes more sense.
Hello and welcome. This lecture we're going to be sorting out the colliders on our barrels so that we can stack them up properly, as you can see here, and have fun just ploughing into them and knocking them down. Let's dive in and see how this is done. Okay, so I would like to be able to stack items on top of this rack. Now, we can do this fairly straightforwardly by just getting a barrel and dragging it onto the rack, and you can see Unreal automatically tries to position it on top, and we can do that effectively. Then we can hit Simulate Physics, and we can hit Play and see that it jumps around a little bit, but not massively. So that's quite cool, and we can now shoot at the rack and have everything fall down in the process. It's funny, it's kind of got its legs stuck in the ground though, which is a little bit annoying. We will work on tweaking some of these bugs. It may well be that the mesh is a little bit too far on the ground. If we select the mesh and the barrel and bring it up slightly, then it shouldn't be penetrating the ground and hopefully won't get stuck in the way that it just did. And we've got a little bit of a fun setup that we can knock stuff over. However, you will notice if you tried, or did try earlier, to stack these barrels on top of each other, they can get pretty unstable pretty quickly, even if we give them a little bit of separation so that we know they aren't clipping into each other and popping because of that reason. If we give them a little bit of separation, let's just select them both because they haven't got physics enabled. Let's select them both and add physics. If I duplicate this, bring up another level, and make sure my tower is nice and straight. And if we hit play now, we see that it pops up in the air like this and is incredibly unstable. So why is it doing this? Why is it being so unstable? Now, the reason for this is because of collisions and the way collisions are calculated in Unreal. There is a mesh here, which is essentially, let me show you what a mesh is actually. If we go to the viewport and hit the button that currently says lit and select wireframe instead, this is what the mesh is. This is essentially what the computer is seeing and rendering for us with the application of materials. So you can see there's this complicated looking mesh for the barrel. But this isn't what is used for physics. No. For physics, there is a simplified version of this mesh to make physical calculations a lot easier. So if you click where it now says wireframe instead, we can change the view mode down to player collision. And this shows us the simplified collision mesh. And you can see it's a little bit wonky, it's a little bit jagged, and not ideal for having clean collisions. So we can change this. We can modify the collision mesh fairly easily in Unreal by going to the content drawer and selecting our barrel mesh and double-clicking it, which brings up the static mesh editor. And we can see...
Wait a second. That's why collision. Way bigger. 5. Now did it think?
what the mesh is like. We can kind of click on it. We can look at the wireframe view again by clicking on lit and switching to wireframe or switching to player collisions. And what we can do is there's a collision button in the toolbar, and we can click on that and click remove collisions, which is going to
pretty cool. Cool. Let me. Probably now. Wireframe, where's the
to remove any collisions that are currently there, such as our slightly janky collisions. If we go back to the main level, you can see there's now no mesh visibles in our player collisions, and if we hit play, you can see they just pass straight through the floor because there's nothing for them to collide with. So what we need to do is go back to our mesh editor and select the collision drop down again, and we can add in a simplified collision that is going to be much better suited for this. And what we want to do is add the 10 DOP Z-axis simplified collision. Now, let me just explain this. In fact, the tooltip kind of explains this. It says it generates a new axis-aligned box collision mesh with 4 Z-axis aligned edges beveled and 10 total sides. That's pretty confusing, but if I add it in, it might make it a little bit clearer. I've added in, you can see this is what the mesh actually looks like, and you can see what it's sort of meant by Z-axis aligned.
Okay.
Most of its complexity is around the Z-axis, trying to wrap around this barrel, and it's flat on the tops and the bottoms, which is exactly what you want really when you're trying to
Pretty
model.
cool.
A barrel. So I'm pretty happy that that's a good collision mesh. We can now save the mesh, go back to our level, and you can see that the player collision view is showing us the new collision mesh, which is a lot simpler and less deformed. So I can now switch the view mode back from player collision to lit, and we can see all the lighting and materials. And we can go ahead and hit play now, and you can see that these barrels are a lot more stable than they were previously. Obviously, when I go ahead and hit them, they aren't anymore. So I'm going to challenge you to create a blueprint barrel class here so that we don't have to go and change settings on every single barrel all the time. So go and click that convert to blueprint button, just a reminder, it's the one in the details pane that looks like a little tiny blueprint graph. Then you're going to keep the defaults and just change the name, and remember that we use the BP underscore naming convention. I'd like you to increase the barrel mass. At the moment, they're very flimsy and fly around very easily when hit, and build a wall out of this barrel class and have fun knocking it over. Pause the video and have a go.
Alright, alright. Oh shit. Bye. Simulate physics. Yeah, the I Or here. What? The player nice and clean. To be like way better now that the
Okay, welcome back. So let's create a barrel class, shall we? So I'm going to take one of these barrels and I'm going to hit the convert to blueprint. Then I'm going to change the name to BP_barrel. And I'm going to change the path as well so that it's in the root of the content folder and hit select. Then it's going to automatically open up our newly created class. I'm going to dock this to the main window and I'm going to go and select the static mesh components, scroll on down to the physics section, make sure physics is enabled. It is. I'm going to increase the mass to about, I think 1000 in my testing has been quite fun in the past, and I'm going to save the blueprints. And now I'm going to delete the barrels that I currently have in my scene because I want to use my new barrel class instead. Then we're going to go ahead and open up the content drawer and drag in a barrel instance into our scene. And I want to stack these up into a wall. Before I do that, I'm going to stick them inside a folder. So I'm going to right-click in the outliner on the newly created barrel, and I'm going to select the Move To option, create new folder, and I'm going to call this barrel wall with no spaces, just because that's my preference there. And then selecting that barrel, I'm going to alt-click on the Z axis to drag the barrel up, and then repeat, and probably one more time to make it nice and tall. Then selecting all 4 of those, I can duplicate out to the side a couple of times. Then selecting all the barrels in the outliner and moving myself to the side, I can alt-click on the red arrow to bring a couple of rows backwards of my barrels, like so. And we probably want some stacked here on top of the rack as well. So let's go back to a content drawer and drag in from there a couple of barrels for our rack and some for the top as well. And while we're at it, let's stack a few of these on top of each other. Should make them more fun to knock down when we do. So let's play and see what this looks like. So I've got my barrel wall dominating here in front, and I've got the rack. Let's try shooting at the rack. Well, that's very satisfying to knock those over. And then we can shoot at this barrel wall as well and create a lovely bit of carnage. Now, you may notice that occasionally the ball goes flying through the walls or the barrels, and this is because it's moving so fast that the physics simulation doesn't really keep up. Now, we won't be fixing it in this section. It's a little bit beyond the scope of what we're trying to do. So one thing you can do to ameliorate this if you want to is to reduce the speed of the balls, and it'll happen less often. Great stuff. So hopefully you've enjoyed putting some barrel physics in here and getting the colliders working. And I'll see you in the next
Yeah, it was fun.
Hello and welcome. In this lecture, we're going to be using variables to keep track of how much ammo we've got. If you look in the top left corner, you can see that it's telling me the ammo value, and each time I fire, it is decreasing that value. Let's dive in and find out how variables help us do this. So we're going to need variables in order to keep track.
1 second, my guy.
Of our ammo. So what are variables? Variables help us store, manipulate, and refer back to information, and most crucially for us, it's going to be that storage of the information. So it's a bit like a box that we label as ammo, and inside it we can put a value.
Fuck this space bar. Goed.
Such as 20, which tells us how much ammo we've got left. So each variable has to have a name. It contains some data, such as the data value 20, and crucially, each variable is of a particular type. So in this case, the ammo box could be said to be an integer because it contains whole numbers. You can't have half a piece of ammunition, so it makes sense for it to be an integer. Now, how would we go about creating a variable in Blueprint? So let's head over to our blueprint panel and close down the details pane. For some reason I have that open. What we need is a different pane. I'm going to go to the window menu and we're going to click on the My Blueprint element there. And this is going to give us a new pane that allows us to add things to our blueprint that we couldn't do before. Here you can see there is a variables section and a little plus button. So let's click the plus button, see what we get. Okay, so we're starting to see what I told you. We've got a name that we have to enter for our variable. We're going to call it ammo. And then next to that we have a type. You can see it's defaulted to it being of Boolean type, but we can click a drop down and we can see all of the types available to us. There's quite a few. In our case, we're just going to go for a straightforward, simple integer, like so. Now, what can we do? How can we manipulate the value in this variable? Well, for a start, it has a default value. If you go over to the details pane, which we closed, but it has popped back up here, you can see that it says, please compile the blueprint to be able to set the default value. So to compile the blueprint, we go to the toolbar and it's the leftmost button. There's called compile. It's got a little question mark to it. I can click compile and then it goes into a green arrow. And now you can see that the default value can be set. So if I wanted to, say, have 20 ammo to start the game with, I can just type the value 20 in here, and that's going to be the value when we start playing. But what if we want to update this? As indeed, we do want to update our ammunition value as we go through playing the game. Well, you can drag a variable from the My Blueprint pane into your event graph. And when you do that, it gives you two options. You've got the option to get the ammo, in other words, to get the value stored within it, or we've got the option to set the ammo, which would allow us to overwrite the value that's currently in there. So let's have a look at what both these nodes look like. And by the way, you can control drag a variable to get it, and you can alt drag a variable to set it. Now, noteworthy is that the set needs to have some execution pins to tell it when to overwrite, because it does make a difference when you overwrite. It is going to have different effects on your gameplay, whereas it doesn't matter when you get a variable, so it doesn't have any execution pins there. And then you notice the key difference is that the getter only has an output data pin and the setter has an input one, so that you could set a different value. And let me just show you that we can get the value of our ammo in begin play. So at the end, when we've done welcome to warehouse wreckage, get ready to rumble, we can put in a new print for the ammo here. So I'm going to drag off and create a new print string node, and in here I'm going to control click my variable and drag it into the scene, and then connect up my ammo to the print string. It automatically adds in a little conversion node so that we can convert from the integer that's given into the string that's required, and we can hit play, and sure enough you can see the value 20 gets printed out there, meaning that our current ammo is what we set it to. Now I just want to show you one more piece of the puzzle here which would allow us to subtract ammo. What we're going to have to do is, after we have spawned our projectile and given it an impulse, we're going to want to first of all get the current ammo, going to want to subtract 1 from that ammo and then set it back. So there's 3 steps to it, but the step that we're missing is how do we subtract? Well, if you right click anywhere in the event graph, you can just search for subtract, and it gives you this little default subtraction node which you can plug anything into. So if you plug in an integer, then it will expect an integer in the second pin as well. So let me challenge you to subtract 1 from the value we've currently got in our variable. So get the ammo value from the variable by using the control and drag to get a get node, then subtract 1 from it using the subtract node, remembering to put the getter into the input pin and then just type in 1 into the other pin. Then store it back in the ammo variable by dragging in a set node by doing an alt click and dragging in the set node. And finally, print the result afterwards using a print string node, and make sure that all of your execution pins are connected up in the order we've just described. Pause the video and have a go. Okay, welcome back. So first things first, we're going to control click in to get the ammo, and we're going to plug that into the first pin of our subtract node. And you notice that then the second pin becomes green as well and allows us to enter a value. I'm going to enter the value of 1. So I've got the ammo value, subtracting 1 from it. So the output is going to be the current ammo minus 1. So initially it will be 20, then it will be 18, etc, etc. Then with that output value, I want to set my ammo. So I'm going to alt click the ammo and drag it in. And then I'm going to connect up the output pin from the subtraction to the input pin of the set. And then I need to connect up the execution pins so that the set happens after add impulse. And then I can take the output value from set if I want to, or the output value from the subtraction. Either one of these will be the same. And I can feed that into a print string node, or I can't do it directly into a print string node because it doesn't know that I can do the conversion. So I need to pull in a print string node, then connect up the output pin from set to the input pin of that print string, and move around my conversion node and connect up the execution pins. Now if I go ahead and hit play, you can see it says my ammo is 20, and if I shoot, my ammo goes down to 19, 18, 17, and so on. I can keep shooting until I get down to 0, but I can keep going. I can go into the negative numbers here because there's nothing in my code that tells me to stop. Well, we'll figure that one out in the next lecture. I'll see you there.
Oh,
Hello and welcome. In this lecture, we're going to be actually restricting the amount of ammo that we have so that once we have used it all up, we can no longer spawn projectiles. See, I've run out of projectiles and I'm even getting a message saying that I'm out of ammo. I can't spawn anymore. So let's dive in and see how we do this. So ideally what we want to happen is when our ammo goes down to 0, we are no longer able to spawn new projectiles. But how do we control the flow of our code via values in our variables? Well, the solution to this conundrum is something called the branch node. So branches let us check if something is true or not, and then do something based upon the result. So you might have a branch node that looks like this, that says if I am hungry, so the condition is I'm hungry, then eat junk food while the wife isn't watching, and if that is not true, then keep playing video games. So these branch nodes allow us to do one thing if a condition is true and another thing if it is false. Either one of these options could actually not do anything, so you could only connect up the false node or you could only connect up the true node. Either one of these is going to work. So you'll remember that, or you may remember that the color red was associated with Boolean type variables in Unreal. So let's remind ourselves, what is a bool? A bool is short for Boolean, and they are types that can be store one of two values, either true or false, yes or no. They're often used with if statements or branches. So in the future, in C++, we're going to be calling branches if statements, but it's the same thing, the same concept. And they can control one graph and another. If two here is actually fit, and basically when we're out of ammo for this lecture, I will see you in the next one. Hello and welcome. In this lecture, we're going to be taking our mess of blueprints and organizing it neatly into functions so that we can easily read and understand what's going on in our blueprint event graph. Let's dive in and see how to do this. Now, if we zoom out on our event graph, we can see that it's starting to get very noisy. I can also see a couple of nodes that aren't connected up to anything. There's a get ammo node, which I'm going to delete, and a set ammo node. But you can see it's getting very noisy. It's getting hard to understand what's going on here. Now, a typical solution that people do is to say, well, this block of nodes here is all about spawning the projectile. So I can select these. I can hit the C key, and it is going to put a block around this called a comment block, and then I could type in spawn projectiles, and that lets me know what that block of code is doing. That is certainly one way to organize your code. However, in my opinion, it's not the best way, and we have got better tools for doing this called functions. So what are functions? Functions execute blocks of blueprint. You go and zoom in, say, on our spawn actor projectile node. That is a function. When we look at add impulse, that's a function too. In fact, every one of these nodes, even things like get forward actor vector that doesn't have an execution pin and isn't blue, is also a function. You can tell because it has a little F symbol in the top left. That stands for function. But we aren't restricted to the functions Unreal provides. We can create our own functions too, and it's really easy to do in Blueprint. They allow us to stay organized, and they allow us to reuse blocks of code. So that's better than a comment, because a comment you have to copy and paste, whereas a function allows us to share one block of code between multiple places of use. So let's take a look at how we can turn something like this into a block of code. Well, we can delete the comment block, first of all, because I don't think that's necessary. Instead, I'm going to select all of the nodes from get player pawn all the way to add impulse, right-click on them, and select collapse to function. And that creates a new block and replaces all of those previous nodes that were there before. Now I'm going to give this function a name. You can see over in the left-hand pane, it's created a new function under the function section in the My Blueprint pane, and it's got it selected for me to automatically rename, because we should definitely rename these functions, and I'm going to call it spawn projectile. And good naming is absolutely vital in programming, because code is essentially all about communication. We're trying to communicate with ourselves so that we can understand what we've written. We're trying to communicate with ourselves in the future when we come back to this project and have forgotten why we've written it a certain way. And when you work in teams, you're trying to communicate with the rest of your team too. Some say that a good metric for code quality is the what the hecks per minute. So if you're reading a piece of code and you're going what the heck 50 times a minute, that's pretty bad code. If you're reading it and only going going what the heck once or twice a minute, then that's probably pretty good code. And you're always going to get some what the hecks, so we're just trying to reduce that number. The functions, crucially, we tend to name functions as verbs. There are some exceptions to this rule that we'll talk about later on, but mostly functions are things that are doing something, so we use doing words. And if you're unsure about how to name this function, then if you're working in a team, you could just talk to somebody else and ask them what they think you should name it and what kind of things make sense to them. You often find that you're so ingrained into a problem that you can't think of how to talk about it. So you may be asking yourself, well, where did all my code go when I created this spawn projectile function? Well, you can get back to that detail of how this function is actually implemented by either double-clicking it in the event graph or clicking on it in the My Blueprints tab, or double-clicking it on the My Blueprints tab, and you can see that we've got all of our nodes still resident here, just now they're in a separate tab. So you can go back to your event graph tab, or you can dive in to the spawn projectile tab, which shows just that one function. And you can see there's a new node here, this little purple node, which is the entry point to our function. This says this is what we should do when the function starts. It's just an entry point, and whenever it's called, that node is going to trigger and trigger all the rest of the nodes inside of our function. So going back to the event graph and zooming out, maybe bringing our nodes together a bit now that we've made our node graph so much smaller and easier to read, I think there are a couple of more candidates here for us to pull out functions and replace things. One of them would be where we are printing out ammo. So in this case, printing ammo is something that we do in two places. We do it in begin play, and we do it down in spawn projectile. And then the other piece of functionality that we could extract into a function would be where we are decreasing the ammo. That could be put into a decrease ammo function instead. So just before I set you the challenge, I would like to delete the conversion node and print string node after the spawn projectile, because this is going to complicate matters. I would like to copy the functionality from up above so that they both look exactly the same. So if we copy the three nodes from begin play, paste them down below and connect up the execution pins, then you can see we've got exactly the same set of nodes here, the same functionality between the two, and there's no confusion when we come to extract this into a function. So I'd like to challenge you to make some more functions. The first one I would recommend doing is the decrease ammo, so taking the three nodes involved in decreasing ammo, extracting those into a function and giving them a name. And then the second one is print ammo. So there you're going to be extracting out the functionality of getting, converting, and printing the ammo into a single function. And because we've got two sites where we're printing ammo, you might want to delete one of them and bring in the function instead, which you can do by dragging from the My Blueprint pane. And then finally, we've got a couple of welcome messages, a couple of welcome message nodes. You could extract those into a print welcome messages function as well. Pause the video and have a go. Okay, welcome back. So we're going to extract our decrease ammo first. So there's three nodes involved in that. We'll right-click, collapse the function. Then we're going to call it decrease ammo. And that's fairly straightforward. So spawn projectile, decrease ammo, and then we are printing the ammo. So let's take the three nodes, the get, convert, and print string. And we're going to right-click, collapse the function, and call this one print ammo. Now, as I said, we've got this functionality repeated in two places. So we'll delete where it does this in begin play and just drag in print ammo from our functions list and connect up the execution pins so that it runs after our print string. Which brings me on to the last function I wanted to create, which we said we'd call print welcome messages. So I'm going to select the two print strings after begin play, collapse to function,
already knew that,
and call it print welcome messages. And this node, we can just now rearrange all of our nodes to make it far easier to read all of this in one screenful. You can see it's much easier to understand the functionality of our game now because it all fits on one screen and is nicely brought to a similar level of abstraction and understanding. And this is what we would call self-documenting code, because it is code that doesn't need comments or documentation to explain what it does. It just reads like English.
Yeah, but your code is... shit. Mine is better. Suck all my nuts, suck all my nuts. color. Cabin. Bang. I've
I'll see you in the next lecture.
Okay.
Hello and welcome. In this lecture, we're going to be looking at creating our own functions from scratch, how we can add inputs to the functions, and how we can add output nodes too. Let's dive in and see how this works. So last lecture we saw how we can extract functions out of functionality that's already there. But what if we wanted to create a new function from scratch? Well, the way we can do this is over in the My Blueprint pane, we can click on the plus button. That allows us to create a new function, and I'm just going to call this one test because it's going to be our little test function. And you can see it's automatically opened up the function tab, and we can see the function node, entry node here, and we could pull off of the execution pin and start adding stuff like print string, which says hello, or just in this case we'll say test. And that could be the whole of our test function. If we wanted it to be, then we could go to the event graph and we could pull that test function in and hook up the execution pins to do whatever it needs to do. I'm going to delete that in the event graph though, because we don't need it there. However, I want to show you a little bit more about functions, because previous nodes we've seen, if we go into spawn projectile, for example, you can see that functions can have input pins and output pins. How do we get those on our own functions? Well, if you select the function by left-clicking on it in the My Blueprints pane, and then looking over into the Details pane, you can see that there's a section for inputs and a section for outputs. So if I add a new input, it's very much like adding a variable to the My Blueprint pane, in that I can give my input a name, such as test1, and I can give that input a type as well. So I could say that what I need to come in here is a vector, for example, or I could say that it was an integer, and then I can make use of the value that comes in within my function. So I could be printing out the value of test1 integer. And interestingly enough, if I bring that test node into the event graph by dragging it in, you can now see that its inputs include that new input that I've created. Okay, that's great. Inputs work. Now, what about outputs? Well, you've got an outputs section. If you click add there, then what happens is it creates a new parameter, which I could call out1, and I can give it a type, such as integer or vector, whatever I want to pass out, what value I want to pass out. And you notice that in the event graph for the function, it has added a new return node. So this is where we plug in the output that we want. So in this case, I could take the input, I could add a multiply node, and I could multiply it by 2, and I could connect that up to the output node. And you see that the output node also has an execution pin. So if I wanted my function to return this value, I need to hook up the execution pin so that when we're finished with all the functionality of our function, it goes to the return node, and then from this return node it would go to the event graph, to the wherever it goes next, to the output execution pin, and you can see then it would also pass out the value that we passed. So you can see it's quite easily that it's patching in from the left side, it's going into the leftmost node, and then once we get to the return node, it's going back up to the event graph and carrying on with its job. So we dip into the function and we come back out again. So one example of a case where we've got a function that we could extract that has an output parameter or a return value is our ammo, where we get the ammo and we check that it's greater than 0. We could turn this into a function to make it even more readable and understandable. So I'd like to challenge you to do that by extracting a hasAmmo function. You're going to have to figure out what the inputs and outputs are, if there are any inputs, and if you click extract, actually it's going to do that for you. So if you select those two nodes, right-click, extract, it's going to automatically figure out what your inputs and outputs should be. And essentially it does that by figuring out which pins there are. And then you may need to connect up some execution pins on that function so that hasAmmo is run before our branch node, and check that it all works the same as it did before. Pause the video and have a go. Okay, welcome back. I'm going to right-click, when I've got these two nodes selected, get ammo and the greater node, I'm going to right-click and collapse the function. And you can see that automatically it detected that we had a data pin that was going outside of those two nodes selected, and so it created a Boolean return value here. So while I've got the rename functionality selected, I'm going to type hasAmmo here. And by the way, you can always go and rename the function by clicking on it, slow double-clicking on it, and you can rename it in the My Blueprints pane. So you notice now we've got these execution pins, so we need to make sure that hasAmmo is run before we need to use its condition return value. So we're going to hook up the spacebar pressed to the input execution pin and then the output to the branch node so that hasAmmo is run before.
Wow,
like
just like I did.
Let's dive in to hasAmmo and see how it's connected things up. So we've got our start node here, and then we've got the two nodes that we extracted, and we've got a return node with that value hooked up to our greater than node. So you can start to see how these return nodes work, and also you can see in the details pane that we've got no inputs because we didn't need any inputs. It's automatically taking the value from get ammo, but the outputs, it has added in a return value of type Boolean automatically for us, which is fantastic. And now we understand how this return node works and how powerful it can be with functions. Great stuff. I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to be learning how we can remove execution pins from our own functions and how and when it's a good idea to do this. Let's dive in. So it's a little bit weird that our has ammo function now has execution pins when previously we didn't need that. That's kind of made our code a little bit worse. So what is that? Why has that happened? And why do some function nodes require execution pins and other ones don't? Well, it all comes down to something called a side effect. So what is a side effect? Essentially, a side effect is when a function has some sort of observable effect after it has been run. Now, what do I mean by this? Let's have a look at some examples of functions with side effects so that you can understand. Print string. After you have run print string, it is quite clear that something has happened because there is now a string on your screen. You can see that there is a string. Add impulse. That clearly has an observable effect because suddenly the thing that you've added impulse to goes flying off into the distance. Set ammo has an observable effect because after you've set ammo, the value in that variable has changed. Now, at this point, you might be wondering, well, surely every function has an observable effect. Otherwise, what is the point of it? Well, not quite. There are such things as pure functions. What is a pure function? It's basically a function with no side effects. However, it does have return values. So there are values coming out of that function, and that is the entire purpose of the function, is to calculate and give us those values. So again, let's have a look at some examples because this will make it a lot clearer. Get ammo, that is a pure function. It has no side effects because you can get ammo as many times as you like, and unless you do something with the value that you got out of it, your program, your game, is not going to be any different. You can just keep getting ammo all the time, all the way through your game, and nothing is going to be observably different about your game. Get actor forward vector. That's another one where you could get it as many times as you like. It's not going to change anything until you do something with the value returned. And all these mathematical functions like multiply, minus, greater, all of these nodes don't have an effect on your project until their results are used for some greater purpose. So these are called pure functions, and you can probably see that these are exactly the nodes that didn't have any execution pins because they don't need them. It doesn't matter when I run get ammo or whether I run it 50 times or one time. It's not going to matter because it's got no observable side effects. So how can we indicate to Blueprint that a function is pure? Well, let's have a look at my test function here. So I'm going to select it in the event graph or over in the My Blueprint pane. And you can see that in the details pane, there is a checkbox labeled pure. So if you check that checkbox, notice the execution pins just disappeared. And all we've got now are the input and outputs of this function. Now, this function will get run whenever we need the output. So if I plug this output into a print string, then it's going to run this function before the print string so that it has the result in time to execute the print string. We can do the same with any function where there are no side effects, where there are no observable effects, such as our has ammo function. So I'd like to challenge you to make has ammo into a pure function. So select it and set that checkbox to make it pure. And what happens to the execution flow now? Currently it was hooked up through the function. Where does it go? Pause the video and have a go. Okay, welcome back. So let's select has ammo. We'll check the pure checkbox. And instantly you see that the execution pins disappear and the execution flow that previously flowed through has ammo is now going directly on to our branch statement, which is exactly what we want. Now has ammo is just going to be run as soon as the branch statement is run to get hold of the return value. Now, a word of caution, only use this pure checkbox when you are sure that a function has no side effects. Common cases and use cases for this are when your function is simply trying to calculate a value, such as has ammo. And that is why this function doesn't follow the convention of having a verb naming, because it isn't doing something, it is getting something, or it is answering a question. In this case, the question is has ammo. And in fact, we could even put a little question mark in our function naming, something that you can do in Blueprint that you can't do in C++, which allows us to see that, yes, this function is answering a question, it isn't trying to do something. So often the distinction between pure and non-pure functions are whether it fits with a verb or whether it fits with a question. So to review, let's have a look at our glossary. A side effect is an observable effect of a function we've seen, and we've seen examples of those functions, and a pure function is a function with no side effects, such as these getting functions or question answering functions. That's it for this lecture. I'll see you in the next one. Hello and welcome. In this lecture, we're going to be learning about functions that live not in the level Blueprint, but on a particular Blueprint class. These are called member functions and are absolutely crucial to object-oriented programming. Let's dive in and see how they work. So in our spawn projectile function in the level Blueprint, we've got a load of nodes here relating to adding the impulse, getting the direction of the impulse, and getting the static mesh component. All of these nodes use the BP projectile instance in depth. Wouldn't it be great if we could take all of this code and move it into the BP projectile so that the code that deals with that data lives with the data itself? Well, that's the entire point of object-oriented programming. So we can define object-oriented programming as functions living with the data that they manipulate. So how does this work? How can we make functions on particular instances of things? Well, one way we can do this, we go to open up our BP projectile class and make sure we click Open Full Blueprint Editor. Is you can see that in this full blueprint editor there is a My Blueprint pane and a function section. So we can hit the plus arrow here to create a new function on the BP projectile class. And I'm going to name this function print your name. And this print your name function should do just that. You can see we've got a node that starts the execution of this function, so we can pull off its execution pin and type print string, so that's going to print out hello. Not exactly the name of this function, is it? But we'll sort that out in just a second. So what we've got here is known as a member function. A member function is a function on a class that always gets called on a particular instance of a class. So you don't say, I'm going to call print your name on all BP projectiles. You have to say, I want to call print your name on BP projectile number 1, or BP projectile that has just been spawned. So if we go to our level Blueprint, what you would have to do is take the reference that came out of spawn BP projectile, and from that reference you could call print your name, and you can see it automatically connects to a special input node called target. And obviously you've got to hook up your execution pins as well. I'm going to hook it up to happen after our add impulse. But what's interesting about this special target input node is that if you go over to the BP projectile, you'll see that print your name has no such input node. So what's going on here? Well, implicitly, any member function has a parameter which is its current target, or the current instance. And you can get hold of this by right-clicking in the Blueprint event graph and typing self. And you can see there is a node called get a reference to self, and it just creates a self node like this. And then you can use this self object reference to get hold of any of the properties on this particular object. So if we wanted to get hold of the name of our BP projectile, you can pull off of the self reference and type in get display name, which we've done before, and then you can hook up the display name into our print string. So now when we play and we fire off a new projectile, you can see it's printing the name of the projectile. And you can see for every new projectile I create, the name is a different one because the self that's being referred to by the member function is a different self. It is a different projectile. So we've learned that self is a node available inside of member functions that always points to the specific current instance that we are using. So the whole point of looking at member functions in the first place, the reason we started was because of these nodes in the level Blueprint, where we get the static mesh, we get the forward vector, and then we add an impulse to these. These feel like they should live on the BP projectile, and so that's what I would like to challenge you to do. So this is a bit of an involved challenge, but we're getting towards the end of the section, so I will take you through step by step. So we're going to make a launch function on the BP projectile. So create it on the BP projectile, go to that plus button, add a new one, name it launch, then cut and paste the nodes over from the level Blueprint into this newly created function of yours, and make sure you hook up execution pins and etc. Now, you're going to try and compile. We haven't done this very often in Blueprints, but compiling...
Spawn What is going on? What? Brrr.
But to see the name of the ship was the Billy O.T. The winds blew hard, her bow dipped down below me, bully boys blow. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. She'd not been 2 weeks from shore when down on her a right whale bore. The captain called all hands and swore he'd take that whale in tow. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. Before the boat had hit the water, the whale's tail came up and caught her. All hands to the side, harpooned and fought her when she
Elf.
Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. No line was cut, no whale was freed. The captain's mind was not on greed, but he belonged to the whaleman's creed. She took that ship in tow. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. For 40 days or even more, the line went slack, then tight once more. Our boats were lost, there were only 4, and still that whale did go. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. As far as I've heard, the fight's still on. The line's not cut and the whale's not gone. The wellerman makes his regular call to encourage the captain, crew and all. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go.
What you think about when you're born into a fire? Let 'em burn it out. Sell 'em to the richest buyer.
Let me see.
They tell us lies and fade away. We feel betrayed. We were raised to lose the race. Wake at the back of the pack, kill it anyway. Listen up now.
Oh, they're home. Ah, yeah, of course. What the fuck? Is it spawning, but it's not applying the... Fine, but too little. The dude do. Kind of too close. Fling! Yes.
Just allows you to essentially spell check your code and make sure that there aren't any errors that the Blueprint compiler can foresee. So the way you do this is you go to the button in the top left and you hit compile, and if there are any errors they will show up at the bottom in the little pane called compiler results. You can see I've got compile successful, but any errors will show up here, and sometimes you'll get a little bit of red on a node to indicate where the error is. And I'd like to see if you can try and understand what call that new project launch to name the function that, from launch to add impulse. And now I'm going to hit compile, and you see I get an error on the static mesh or get static mesh node. And if you look in the compiler results, it says it uses an invalid target. So target, this input here, is not correct. Now, as I recommended you do, is you can right click and type in self to get a reference to self, and then bring that self into the target instead. Now, if you hit compile again, you can see the error has gone away and it's compiled successfully, because what's going on is that it's now able to get the static mesh component from the current projectile that this launch function is being called on. So if we go back to our level blueprint, now we can take the output pin from our spawn actor and we can type in launch to call our launch function. You can see the execution pin was automatically hooked up for me. And then after the launch function, we can hook up our print your name function if we want to, although that was just for debugging and demonstration purposes. And if you test it out, you can see that it's still launching successfully, except now the code that deals with launching lives on the projectile itself. Great stuff. We've learned about one of the cool concepts of object-oriented programming in this lecture, member functions. I will see you in the next one. Hello and welcome. In this lecture, we're going to be making it so that when you use up all of your projectiles, your game will automatically restart the current level after a pause of 5 seconds. Let's dive in and see how this is done. So one element of this game that's not particularly fun right now is that when you run out of ammo, it's a dead end. You can't try again, you can't do anything else, you can't move on to another level. Now, the way you can fix this is by allowing us to reload the current level. The way you can do that is using a special node in Blueprint. So if you right-click in the event graph, you open up your level blueprint and right-click in the event graph, we can search for open level. And there's two options here. There's an open level by name and an open level by object reference. We can use the open level by name. So here you've got a node that obviously has side effects because it's going to reload the level, and it has an input which is the level name here. Now, how do we get hold of the current level name? We could just type it in, but what if we accidentally... be renamed this level at some point in the future. Well, what we can do is also right-click and do a get current level name, which gets us another node that returns the current level name. Interestingly enough, this one isn't a pure function. I have no idea why, because it looks like it should be. And what we can do is, even though these two types are different, one of them returns a string and the other one requires something of type name, it's actually possible to very easily convert between strings and names. So we can drag from the return value to the input value, and a conversion node will automatically be created for us. We also need to hook up the execution pins between these two, so we're going to get the current level name, convert, and then open the level. Now, when is it that we want to do this? Currently, everything is happening either on a key event or begin play, but there is another option. What we can do is we can have a special node in the root event graph, so not within functions, but within the root event graph called a delay node. So what we're going to do is after the out of ammo is pressed, we're going to pull off of the execution pin here and search for delay. And then you can see it brings in a special kind of node with a clock on it. And this means that the output happens not instantly after the function has finished, but it happens after a certain amount of time. So you can see we can input the duration here, and that duration could be 5 seconds, for example. So in my print string, I'm going to update it to say out of ammo, restarting in 5 seconds, and then ... And then we can plug in the code that restarts the level into the output, the completed node of the delay node. So if we go ahead and play now, what we're going to see is that I can run out of ammo, finish all of my ammo. I run out, and it says I'm restarting in 5 seconds, and after 5 seconds has elapsed, boom, the level has just restarted. So small challenge for this lecture is to extract a function from those nodes that we've just created, the get current level name and open level, and my challenge to you is to just think of a good name for this function. Pause the video and have a go.
Okay. What is it? They cannot be played.
Hey, welcome back. Well, I'm going to call it restart level because that's what I think it's doing. So I'm going to right click, collapse to function, and call it restart level. And it's fine with the current inputs. It doesn't need to be pure because it has the side effect of restarting the level, so we wouldn't want it to be pure anyway. So that's it. I'm just going to reorganize my nodes ever so slightly and delete my test node and delete my test function by right-clicking on it in my blueprints and hitting delete. And we've got ourselves a condensed little blueprint graph that actually describes exactly what our game can do, just at a very high level. So I'm pleased with the results of that. Feels like we've got a good game loop, and I'll see you in the next lecture. So congratulations on making it to the end of the section and having programmed your first game using the Blueprint programming language. Now, what is it that we have covered over the course of this section? It's been a while, so you may have forgotten how much you've learnt. Well, the first thing we've covered is things like Blueprint basics, nodes and pins and all that sort of good stuff. Now, obviously, that sort of visual element of Blueprint is only applicable to Blueprints, but everything else we've learned in this section is going to be transferable to C++, such as your programming basics, things like variables, strings, references, and functions, and branches. All of these concepts will be very, very applicable in C++ once you've learned the syntax. Then Unreal basics, things like maps and actors and components and transforms and vectors, all of these things exist in C++ as well, and we'll learn how to use them in the next section. And then we've got object-oriented basics, object-oriented programming basics, things like objects and structs, classes, member functions, self, all those things that we've just recently learned. Absolutely crucial concepts to understanding C++. So I'm really thrilled with how much we've covered in this section and that we've been able to create such a cool little game in the process. I hope you've enjoyed it too. Please, please, please share your resultant game in the discussions for this lecture. I love seeing them, and I know that other students get inspired by them too. And I will see you in the next section.
Alright. Now, do something, because otherwise I won't like way I to like. Maybe this. Let's get. Try something. Do a way that I can go over this shit. Size. Mistake. E is the center. And there are setting like you board is for yeah, well, it doesn't matter. Actor begin overlap. This actor begin. I'm not really sure what I am. Oh shit. Oh, it does. That's what I wanted. So when it begins overlapping, what I wanna do is Baseball. Wait. Did this that? I think I can, right? False. False. Yeah, I can do that. That's it, instead of doing a lot of checks. Toggle. Switch. And you do the same thing for the way more sensitive stuff. This is cool, right? Have this. Variable. False. Check the branch. Well, let's make it area. The ammo being set. Oh, it's on the level itself. Text. What? Find variable ammo. I have to get a Oh. Maybe I have to do this like this. What? What's the event name? Carriage. Create this event. Called or function. Yeah, that's what I want. What I really, really want. So tell me what you want. Be right back. I'm back, bitches. Sorry about that. So what's the name? Aye. For this event. Houston event, it is public. Fuck this, fuck you, motherfucker. Fuck you, bloody. mean, my casting is not that good, right? False reference. Also events in the blueprint. Okay. Drag off the event. Don't have an event dispatcher, motherfucker. But do I need an event dispatcher? Add event custom. Custom events provide you with a way to create your own that can be called at any point in your blueprint sequence. Yeah, whatever. I did this. I already did this. I already did that. Calling the custom event. Yeah. Custom event and its associated network have been created. Fire to right click off. All function. My all being here. Why there is here and there is. Tá. Oh, it's here. I have to have the level here. Take, man. Yeah, but how do I call this event from another place, motherfucker? Know how to create it. Swear to God, it's completely different. Where's the... I hate this. How do I do this? It's so frustrating not knowing how to do things. Can have a I really hate this. Let's go. What? It's not even detecting the... Change to another key. Do space bar or whatever. This is not. What the fuck is going on there? Why this is not working? Yes. Why is this not being recognized? I don't know. You know what? Fuck this. Fuck everything. Fuck you. Fuck you. Fuck you. Okay. I'm all set to 20, right? Oh. Wasn't. Did this call even happen? Nothing happens. I think I'm doing the other way around. This is so confusing. Okay. That should do it. Yeah. Oh, for fuck's sake, man. At least this work. At least I did on my own. That's the best way for me to learn. Or that's the way I learn the best. Um, format. Um, okay. Then we go. What? Maximum ammo. Inside, and it is bitty bitty giddy. Yes. Paint. Loading messages in the wrong place. And here. Still reloading. What? Maximum ammo. 20. Why is it reloading? Print code. Oh yeah, dumb motherfucker. Minus only. Stupid fucking whore. Okay, you have full ammo, reloading. Awesome. Yes, 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 yes. Okay, I did what I wanted, so that's nice. Let me do one more thing. One more thing. Just to have some visual feedback. I want to... Can I change something here? Vincent. Let me think. What I can do. If I do no collision, will this still work? Works, so let me gloss statue glass browse statue glass here. Perfect. And now what I want to do is overlap. Say, hey yo! Get your texture. Set the texture. Texture object. It. What? Static mesh pane. Oh, okay. Ah, okay. Materials, not texture, motherfucker. Set materials, yes. Fucking whore. And index, material 1. Glow. Yes! Yes! Bitches, motherfucker! Ta-da! Ta-da-da! 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 Wow! Yes, yes, yes! What I'm talking about. Because I don't need the... Yes, 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 yes. And we can do the set material. That's why I was... Mesh, but I don't need this one. I already have the reference here. And then here we say glass something something. File for... Oh Jesus. File save. Very cool. Okay. Okay. Now let's change this from opaque to something else that is more. Good enough. Nice. Very awesome. Wow. Save all. That's it for the blueprint part. Very cool. I want to test if I could do something by my own. It was enraging, but it was done. Be right back. I'm back. Let us continue.
Hello and welcome to the Obstacle Assault section. This is the first section we are going to be building a game using C++ in Unreal, and the output product is going to be this. At least this is my prototype of the output, which is a obstacle course that you can navigate across. If we go ahead and play the game, we can see what it looks like. We've got ourselves a cool looking character, some moving platforms and various assets, and we have got these obstacles that we have to avoid. They push us off the cliff if we don't get past them fast enough. We've got these Fall Guys inspired rotating platforms that we have to try and traverse, and then this little sweeper here that tries to push us out of the way. And once we get through,
I guess I can show you guys this part so you can check it out. Where is it? Here.
Hello and welcome to the Obstacle Assault section. This is the first section we are going to be building a game using C++ in Unreal, and the output product is going to be this. At least this is my prototype of the output, which is a obstacle course that you can navigate across. If we go ahead and play the game, we can see what it looks like. We've got ourselves a cool looking character, some moving platforms and various assets, and we have got these obstacles that we have to avoid. They push us off the cliff if we don't get past them fast enough. We've got these Fall Guys inspired rotating platforms that we have to try and traverse, and then this little sweeper here that tries to push us out of the way. And once we get through, we get to the goal and to the temple, presumably to steal something. So let's break this down in terms of what we're going to learn. So a bit of an action plan. First of all, we're going to create a project and bring some assets in, so that cool looking guy and the various mountains and blocks that we're going to be using. Then we're going to take a little bit of a detour for about 5 lectures or so on installing the various tools we need for C++ and figuring out how we can compile our C++ to run it in the editor. We're going to learn some C++ basic syntax and figure out how to do very simple things in C++, and we're going to use that to make a platform that moves. Not backwards and forwards, but just moves initially, and we'll keep going for as long as we leave it. And then we're going to configure our moving platform, so we can say, you know, how fast should it be, and then we're going to work on sending that platform back, so we can have a platform that moves backwards and forwards, a classic moving platform. And finally, we're going to add rotation, so that we can add in those little rotating platform puzzle elements as well. So through the course of this section, what are we going to learn? Well, we're going to look at functions, variables, and branches again, except this time we're going to see how we do this using C++ syntax. We're going to create our very own actor in C++, like we've done in Blueprint, but this time in C++. We're going to look at the uniqueness of C++ code structure and how that pans out for our programming. We're going to look at C++ compilation, a process of turning code into binary the machine can execute, and how we can do this easily without restarting the editor using Unreal's live coding system. We're going to link Blueprint to C++ so that we can use the best of both worlds, and we're going to learn how to be setting our own custom character classes so that we can play using not just the standard assets included for us in a template. So lots of fun stuff to learn and great projects to create. I will see you in there. Hello and welcome. In this lecture we're going to be bringing in some asset packs and creating our project so that we have our own level and our own third-person character, as you can see here, this mannequin character here, brought into the level ready to get going. Let's dive in and see how we can get these. So in this section we're going to be using a couple of asset packs. The first one here is the Unreal Learning Kit for Games, which you can see has a bunch of cool cartoony modular assets that we can use to put together
Let me download that then. Library. Learning Kit Games. I already have it.
And make our own game. It also has a character, but we're not going to be using this character. I'm going to be choosing to use this other character from the permanently free collection called the Stylized Character Kit, Casual 1, and this
Stylized guy. Kit Casual 1. Okay, I have both of them.
is by Rocket Arts, and they've made this absolutely awesome looking character that just works when you put it into Unreal, and you can choose all sorts of different skins to put on it if you like. I think this character just makes the game really pop, and there is lots more paid versions of characters, but this is one of the best free ones available in the marketplace at the time of making this course. So what you'll need to do to go ahead and get these assets is, first of all, follow the links in the resources against this lecture to open these up in your browser. Sign in with your Epic Games account. You will click on either the free or the buy now button, which will take you through a checkout process which won't require you to actually pay any money. And when that is done, these will become available in the library tab under the Vault section. And you locate these two. Now, the first thing to note is that with the Learning Kit, there's a slightly different process. You don't bring this into an existing project, you use it to create a project from scratch. So that's what we're going to do. Click the Create project, and they may need to download the assets for you to do this, and you need to choose the closest version to the version that you're using. In my case, it doesn't have a 5.0 version yet, so we're going to use an older version and then upgrade it. So we're going to use 4.27 to start with, and then we're going to name the project, which in my case is Obstacle Assault. And it's important to note that this name can only contain standard ASCII characters, so only basic English characters without accents or umlauts or other kind of diacritics over them. And then we're going to choose where we're going to put this. And I already have a folder set aside for this. We can go ahead and set it in there and go ahead and create your project. And once it's done that, it's going to show up inside your selected folder here, and you can see that there is in there a U project file that we could open. But we want to switch the version so that it doesn't open up with the 4.27 version that I selected. So I'm going to right click on the U project, go to the Show More options, switch
Have to do that
version, and then
show automatically, you dumb fuck. Where is it? Obstacle Assault 5.5. Do 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 do. Do 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 do. Test it. Let me test something here. Okay. It's working. Dumb bitch. You dumb whore, bitch ass, bitch mouse, bitch mouse, bitch mouse, bitch. What is this? Not subscribe. Oh wow, this looks so nice, so beautiful. Bitch mouse, bitch. Ah, this is cool. It has something happening. What is this? VFX pollen. Is there a way for me to open already with that selected or something? This cascade. Let me play it. Modular kit, buttons, dong. What is it? Alternate right mouse. Not working. Some bitches. Circulate. Power it up. Oh. How the fuck I'm flying? But I am. Bow. How do I stop? Okay. Found that bug. Whee! Props, animation. Okay, now we close this guy. Click here. Go. Paste this thing. Add this to the project. What is the project? The oops. Is it obstacle? Work either way, my dudes. My dudes! My best friend dudes. What is it? Meow.
Then from this drop down I can select 5.0 and click OK. Now if I go ahead and double click the new project, it's going to convert it and open it up in Unreal 5. Now you'll see that straight away it opens up into a level that showcases all the assets that we've got available to us. And I'd actually like to use this level as a starting point for building out from, so that we have the assets to hand and we can drag them about and copy and paste them. So I don't want to actually be doing this within the level itself, I want to make a copy of it. To do that we can go to File and Save Current Level As, then go to the root of the content folder and I'm going to call my level Main. And now that we're using a different level, the main level, we need to set that as the default startup editor level, which we've done before. We go to our settings cog in the toolbar, project settings, then we look for maps and modes, and under default maps, we switch both of them, the editor default to the main, and the game default to main as well. So that
wait a second, my guy. First, file, save current level, asshole, content. I like to create maps folder. Maps folder is done. Done. Then we go to settings, project settings, something. Then we do scenes. I forgot it. Oh, it's happen modes and then here. Oh shit, why it's not doing that? Okay. Okay. Die, bitch. Oh, this is cute. Yee-hoo, hoo. Falling forever. Okay, pretty cool. Pretty cool. Very small collision box for this. Not that small. Shift lever on or off at the start. Oi! Severe weather. 5 o'clock! Oh, Jesus.
But next time we open up the editor, it will automatically default to our level and not the one from the starter kit. Now, I don't want the starting point of our game to be this messy little island in the clouds here, so I'm going to zoom right out. And if you want to move faster as you zoom, remember that it is scrolling up that makes you move faster. And you can see there's this little island behind it. I think I'm going to use this as a base for us to start from. And I want to place our character in here, but I haven't brought the character into the project yet. So that is going to be a challenge for you. So I'd like you to import the character pack, download the asset pack, import it into our new project, see if you can find the third person blueprint within that new folder that it creates. It's usually under a blueprint folder, that's the hint there, and see if you can place that blueprint into the scene on one of the islands. Pause the video and have a go.
Of course, I'm not retarded.
Okay, welcome back. So we're going to scroll on down in our library tab to where we have the stylized character and click add to project. Then I'm going to look for my project, which is called Obstacle Assault, and select that one. And now it says there's no compatible version for 5.0, so we're going to use the nearest version. In my case, I'm going to use the 5.0 early access, but you may well have a compatible version and not need to do this, so you go ahead and add to the project. And once that's done, we can head over into the editor, look at our content drawer, and see that there's a new folder at the root of content called SCK Casual 1. We can click into there, you see there's a blueprints folder, I can click into that, and there's a third person character, and I can drag him into the scene. Now you'll notice this third person character doesn't look like the one in all of the pictures, he looks notably more like the mannequin, and that's because the default mesh on this third person character is the mannequin mesh, but we're going to swap that out for a different one, and that's going to be the subject of the next video, so I will see you there. Hello and welcome. In this lecture, we're going to be looking at how we can control
Jesus
our
Christ,
own character,
the difference in
customize the
volume.
mesh, and fix a bug in the camera movements. Let's
Oh,
dive in
fuck.
and see how this is done. So let's look at customizing this character away from this boring default mannequin. Now, you might be tempted to go ahead and just customize the character here in the scene, but I would recommend that you don't do that. Instead, that we create a blueprint child class off of this third-person character. And the way we can do that is by going over into the details pane,
Alright,
and
a
selecting the
blueprint.
blueprint button, and clicking the
What the fuck are you talking about? This is already on Blueprint. What did you do?
create child blueprint class. So that
Ah, okay. That's okay. Child blueprint. PP. Give me the name.
allows us to add our own modifications on top of the character class that we've already brought in. So I'm going to call mine the BP underscore third person character. And I'm going to
boring.
put this at the root of our content folder. So I'll click on the path and select content and then click OK. And then we're going to go ahead and click select, and that will open up our BP third person character and allow us to modify it. Now, one thing you will notice if you go ahead and play in the main level is that it doesn't actually start using our character. It spawns in its own character here, and that's because we've got a player start. Let's go ahead and delete that player start, but even if we do that, it's not enough to make us use the character we've brought into the level. To do that, we have to signal to the engine that's the character we want to use for our player 0. So if we go over to the blueprint for a second here, we're going to go into the details pane and search for auto possess player. And here it's currently set to disabled. I want to select player 0, and that tells the engine that this character should be possessed automatically, should be controlled automatically by player 0. So let's go ahead and save that, go ahead and play in the main level. And now you can see that I have got the character. His arm looks a little bit funky there because we're using the wrong mesh. And I can't move left and right with my mouse. So let's sort out the
Wait. Delete the thing, or did you just set?
character.
Or going to delete it?
And then we're going to get not enough to make our own character here, and that's because we've got a player start. Let's go ahead and delete that player start, but even if we do that, it's not enough to make us use the character we brought into the level. To do that, we have to signal to the engine that's the character we want to use for our player 0. So if we go over to the blueprint for a second here, we're going to go into the details pane and search for auto possess player. And here it's currently set to disabled. I want to select player 0, and that tells the engine that this character should be possessed automatically, should be controlled automatically by player 0. So let's go ahead and save that, go ahead and play in the main level.
Okay, I'm trying to recompile. File save. Okay. Working. Sounds good.
And now you can see that I have got the character. His arm looks a little bit funky there because we're using the wrong mesh. And I can't move left and right with my mouse. So let's sort out the left and right thing first. Now, the reason for this is that our inputs are slightly different to this character than those required or assumed by this starter kit. So what we need to do is edit the casual character's blueprint. So we're going to go into the content folder, the casual character folder, the blueprints, then we're going to open the third person character. So this is a different blueprint to the BP.
It's off. Where's the camera here? Can't see it. I did something wrong. VR. Reference no turn rate. What the fuck is wrong with your arm, my dude? No turn for input.
Third person that we've created off the back of it. And you'll notice in here that there are a couple of compiler errors, and you can click on the little looking glass or the little symbol next to the looking glass to find where these are. You can see that they're related to the turn rate axis event, which is basically how our turning has been set up. Now, we don't need to go into too much detail about what this is. You can see it's an event. It happens whenever you try and turn the mouse or you turn a controller. And it is currently set up to something that is not configured for our project. So what we need to do is right-click in an empty space and search for turn. And you will find that there are some events here. There is an axis event called turn right rate and turn right. We need the turn right rate at the top here to replace this current event, and then we can move the pins that it's connected to by clicking Control and dragging it on.
Turn right. Was it the... Oh, turn right. Turn right. Oh shit! Turn right. Here. Oh, that. Blood, you motherfucker, bloody. I do. Turn, I guess. Right, turn. Right. It. Okay. Let us see. Okay, it works. Pretty cool. Okay.
To the new pins to connect up to the new event. And we can delete the event that has a warning attached to it, move the old one in place. And then there's one more warning for one called turn. We can right click in empty space again, search for turn, find the event called turn right, which we're going to replace it with. Control click on the pins to move them over to the new event. delete the old, and move it into place. So that's just updated this blueprint so that it works with the control scheme configured in the project. And if we go ahead and hit play now, you will notice that we can rotate the camera around and move as we would expect. So I'd like to challenge you to customize your character. You're going to do this by editing your BP third person character, this one here, and particularly the mesh component in the components pane. You're going to select that, and you're going to be using the details pane over.
Yeah. Out, so you're giving me everything that I need to know. Here. What I need to do now is find the motherfucker. Is it? No. I just changed the skeletal mesh. How you doing? Ah, it looks so cold. Looks like someone that orders a
here to
pumpkin spicy latte with almond milk.
Change the mesh to something that you prefer. Try out the different ones and see which one you want to use. Pause the video and have a go. Okay, welcome back. So,
yeah, let me test the other ones.
Property available, which again we go to the mesh in components, then to the details pane, down to the mesh section, and there's a property called skeletal mesh. And then what you want to do is click the drop down and have a little scroll through here to have a look at what meshes are available. Now, some of them come from the starter kit, and some of them come from the character that we have brought in. So I can select. There are a couple of pre-made, fully formed characters in here. One is just in his underwear, and then there's some with different clothing on. I'm going to select number 3, and you can see here it comes in with some pretty cool looking sunglasses, and we can go into our level and see that that character has indeed been updated over here too. So if I go ahead and play, I can now play as this character. His run animations work correctly, his jump animations work just fine, and the camera movement works as well. Fantastic. Let's dive on to the next lecture.
Let's do this one.
Hello and welcome. In this lecture we're going to be talking about compilers and editors, figuring out what they are and why we need them when we want to write C++. So let's start off with a few glossary definitions and we'll see how they fit into the wider ecosystem. First of all, source code. This is crucial to understanding why we need a compiler in the first place. Source code is the code we write. It's usually text. It's a human-readable form of code, such as C++, but sometimes you could think of source code as being blueprints as well. They're human-readable ways of describing what you'd like your game to do, what you'd like the computer to do, and crucially, it's the human-readable part because it's not meant for a machine to be able to execute this, to be able to make it run. That is the role of binary executable. It is usually binary code, ones and zeros, and it is intended for a machine to be able to quickly read it and execute it on your CPU and on your GPU, and so it is machine-readable code. So between these two, there is a gap, and we need to fix that gap so that we can convert our human-readable code into machine-readable code, and that is the role of this so-called compiler. It translates machine.
Yeah, I know all this.
Source code over here. We know that it looks a little bit like this. We've got a
yes. Okay, I don't need. Net. What else? I don't know. I don't want to install fucking Visual Studio.
Hello and welcome to the installation lecture for Visual Studio. This lecture is specifically for folks who are on a PC, so if that is not you, go ahead, hit the skip button. The next lecture will be for you Mac folks who want to install Xcode instead. But if you're on a PC, let's jump in and get downloading this software. So let's have a look at an overview of how to install Visual Studio. The first thing we need to do is check the supported version of Visual Studio for our current version of Unreal Engine. So not all versions of Visual Studio are supported by every version of Unreal, so we have to check that compatibility first. Then we need to download the appropriate version of Visual Studio Community Installer and set that off downloading by selecting the Game Development with C++ workload. There's a bunch of different ways you can use and configure Visual Studio. It's a very powerful piece of software, so you need to choose the different components that are involved in the C++ workload, and then we select install, which is obviously the part that takes the most time. So let's go ahead and first of all check compatibility. So at the time of writing, this documentation page on Unreal Engine is not updated for the Unreal Engine 5, but I can give you the information for that, and it's worth going and checking this page before you install anything, because things may have changed since the recording of this video. So it's worth going and following the link in the resources to have a look at this table for yourself. The table we're looking at is this one here, which shows the compatibility between engine versions. So what you would do is you would look at the version of the engine you have. So for example, we've got 4.25 or later, and you see the supported Visual Studio version here is VS 2019. Now I happen to know that if you're using Unreal 5, the supported Visual Studio version is actually VS 2022. So that is the version we're going to be downloading, and at the time of recording, it's actually the latest version of Visual Studio, but that's not always the case, so you do have to come and check. Then, second link in your resources is going to be the page here for the downloads for Visual Studio, and what we can do is go ahead and click the free download for the Community Edition of Visual Studio 2022. However, as I've said, if you're coming to this page later and 2023 has been released, then that's maybe not what you need to get. So you need to scroll on down the page all the way to the bottom where it says older downloads and select for older downloads. And if you scroll on down, say, have you really tried the latest version, etc. Well, if you need an older version, you need an older version. So you come down, you find 2019, and you can click here to download Visual Studio for 2019. But we're not going to be doing that. We are going to be downloading the Community Edition of 2022. So let's go ahead and select that. It pops up, creates this executable here, and we give it the keys to the kingdom, and it goes ahead, click continue to agree to licenses, and it downloads the installer and installs it, and that's the first step of the process. And once that's done, it's going to pop up with a window that looks like this, that allows us to select the workload we're going to be using with Visual Studio. So what we need to do is scroll on down until we find game development with C++. You can see there's desktop development, mobile development, game development, Unity development. We want game development with C++. And it's also important that we check the Unreal Engine installer checkbox over in the right-hand pane, because this will install a few extra requirements required specifically for Unreal Engine. And we can go ahead and click the install button. You can see that the total space required for this is going to be 7.3 gigabytes. So let's go ahead and install. So that's it for this lecture. I'm going to be leaving it button. You can see that the total space required for this is going to be 7.3 gigabytes. So let's go ahead and install. So that's it for this lecture. I'm going to be leaving it downloading now. There's no point in you watching my screen as it downloads, but in the meantime, get on with the rest of the installation lectures. At the moment, the installer in Visual Studio doesn't actually install all of the requirements that we need. In the future, this will probably be fixed, but for now, you need to follow the link to install the .NET SDK, and when you're here, you need to go ahead and download .NET Core 3.2. Now notice it's pretty old, but this is the version that Unreal needs at the moment. So go ahead and click this. Then for your platform, which is going to be Windows 64, you find the installer linked there. And you let that go ahead and download and then run through the installation process, which is going to be a pretty standard process. So we're just here, I've got it already installed, but for you, it's going to look like this instead. So if you did already have it installed, it will have shown you the previous screen. No need to install it again, if that's the case. But if you don't have it installed, go ahead and hit the install and just run through the setup process, which should be pretty automatic. And this is what it will look like when it's completed, so you can go ahead and hit.
Yeah, whatever. This.
So how are we going to go about installing VS Code? Well, the first step is just to download and run the installer. This is a pretty straightforward step. Same on Mac and PC. We can find the extensions tab. Once that is done, then it should automatically have detected your platform options as well. The first option is the extension by Microsoft. That's the one you want to go ahead and install. And then the next one is the Unreal Engine 4 snippets. And again, there's quite a few extensions here that help with this, but the one you're looking for is the one by Captain Caps. Now, if at the time of recording this one's still called Unreal Engine 4, even though it works just fine for Unreal Engine 5, if this has been renamed in the future, do try searching for slight variations. That might be something like Unreal Engine snippets instead, and you might find it that way. But I'll try and keep the video updated with any changes. So once you've got those two extensions installed, Visual Studio Code up and running, that's it for this lecture. You have successfully got ready to start programming in C++, and I'll see you in the next video. Hello and welcome. In this video, we're going to be creating our first C++ class and recompiling the editor from Visual Studio Code. So at the end of the day, you will have a C++ class that you can locate in your content drawer and a Visual Studio Code project that you can open and compile. Let's dive in and see how. So now that we have all of our tooling in place, it's time to start creating some C++ classes. Now, before we do that, we need to switch our default editor so that we can use Visual Studio Code by default. Now, the place to do this is in the editor preferences rather than in the project preferences, so it is a global setting across your entire editor. So we go to the Edit menu, down to Editor Preferences, that pops up this tab here, and then we're going to look in the left-hand pane at General, and then Source Code, and under there, there's basically one option, which is our source code editor. Now, on a PC, this will default to Visual Studio 20. Down to Editor Preferences, that pops up this tab here, and then we're going to look in the left-hand pane at General, and then Source Code, and under there, there's basically one option, which is our source code editor. Now, on a PC, this will default to Visual Studio 2022. On a Mac, it will default to Xcode. We want to go ahead and change this setting so that we're all on the same page and using Visual Studio Code. When you do that, a little pop-up shows up saying, hey, this setting requires that you restart the editor. So let's go ahead and restart it now. And I do encourage you to go ahead and do this and follow along with me and restart while you're watching the rest of the next steps. So now we don't need our Editor Preferences tab, so we can close that down. What we want to do is create our first class. Now, the class we're going to create is going to be for a moving platform that we're going to program in C++. So the place that we go to create a new C++ class is to the Tools menu and then New C++ Class here. So we click on that, brings up a new class wizard, and this is going to automatically...
Relax, dude. My thing is still loading. What do 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 dee 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 dee. Dee 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 dee. Is it too? And
automatically create some of the code for us to get us started. Now, we want to create an actor because we're going to be placing this in the world as a moving platform. There's a few different options we could have theoretically, but for simplicity's sake, we're going to start off with creating an actor. Then we can click on the next button and we want to give our actor a name. So my actor is a really rubbish name for this. We are going to be calling it moving platform, and I'm going to type it like this with a capital M, moving, and then a capital P for platform. And that, because there's no spaces allowed in the names of classes in C++, this simply allows us to easily pick out the different words by using a capital letter to start each word. So you can easily see that it's moving platforms and not anything else. Then we can leave it in the default location, we can leave everything else as a default, and just click Create Class. This is going to go through the process of generating all of the code and setup we need for C++, because up till now this project has simply been a blueprint-only project, but now it's gone ahead and added all the things it needs to be a C++ and blueprint project. You can see that there's this message will pop up that says, your project now includes sources. Please close the editor and build from your IDE. What is an IDE? Well, IDE stands for Integrated Development Environment, and for all intents and purposes, that just means our source code editor. So what it means is we want to open up the C++ in Visual Studio Code. So we click OK to that, and then the next thing that pops up here is that it's saying successfully added moving platforms, but you must recompile. Would you like to open the code editor now? Well, you should say yes, but I'm just going to show you what happens if you accidentally close this message down by mistake. So we're just going to say no. It leaves us here in the editor. And you'll notice if you go to your content browser, it hasn't added any C++ in here yet, and we'll see what that looks like in just a second. But what you can do if you forgot or didn't open the editor at that point is you can go back to your Tools menu and click here. There is an Open Visual Studio Code option. Now, it's important to note that in recent versions, we also have to click the Refresh Visual Studio Code project every time we add a new class. This doesn't happen automatically for us at the moment, and then you can go on to click the Open Visual Studio Code project button after that. And if you didn't have this option here either, or you had closed the editor or whatever, you can also go to your project in Windows Explorer or Finder, and you can find the .code workspace file. That is the one that you can open, and that will go ahead and open with Visual Studio Code, or you may need to choose to open it in Visual Studio Code, and then this is what you'll end up with. You can see we have got, by default, this terminal will not be open for you, so let's just close that down. And what you will see is there will be two tabs available here, potentially two tabs. They may not be open for you, but you'll have a Explorer on the left showing you all the files in your project. You'll have maybe some code open in the center. It doesn't matter at this stage. We will get to understanding Visual Studio Code a lot more later on. The main thing we want to use it for right now is to recompile our editor binary. So to do that, let's first close down our editor. It doesn't actually have to be closed to do this, but we might as well close it now. And then we need to go to the terminal menu up at the top for Visual Studio Code, then go down to Run Build Task, and you can see that there is an associated shortcut which we'll be using later on. So make note of what this is on your platform. For me, it's Control-Shift-B. I'm going to click that option. And then what you want to do, you can see I've got a recently used task in here, but you will not have a recently used task. You'll need to scroll on down to find that task, which for me isn't in the options, but the important thing to look for is that it says Editor. So we've got Obstacle Assault Editor, then Development over here, and then Build. So we want Editor, Development, Build. Let's go ahead and select the option that matches that for you. The platforms may be different. You can see that there is an iOS platform.
Working. For me, this is not working for me. For me. Well, he's installing a lot of stuff. So, and it's late already, so I'm going to go. Tomorrow we'll be back, ready to do some programming in C++. Fun. First time ever touching a C++ code, so that should be fun. See you guys tomorrow. Kisses.